In this video, we are going to kind of define a limit a little bit better, but we're going to use an example to then define exactly what a limit really needs to be. So we have this function that is x to the third minus 8 over this 4 times x minus 2. Right away, I see that x cannot equal 2 because it's going to cause the denominator to be 0. So I have a domain issue. And if I didn't have these graphs, then I would be saying, well, I don't know what kind of domain issue I have. I need to kind of do some pre-calc and examine it a little bit more. But if I graph it, and here's kind of a chunk of the graph, and here's kind of a little bit of a bigger chunk. So all that is just kind of from first quadrant-ish. And so if you look at this, it doesn't seem to have a problem. However, when you go to the table, here's where you can definitely see your problem. Right, here's that 2, it's causing an error, but it's not causing an asymptote, it's causing a hole, right? Which also means that if you were to factor this right here, it would also have an x minus 2, and so you can cancel things. So here's really what we got going on. So for us to look at the limit and to really define it, technically, we have to look at the limit on both sides and see if they're approaching the same y value in order for our overall limit to exist. Right, so we have the limit as x approaches 2 from the right of this problem. And that's going to get us a 3, right? And so we're approaching it from the right. If we approach it from the left, as x approaches 2 from the left, that means we're coming this way. And we're approaching the same y value there. So that means that our overall limit as x approaches 2, you have to compare both sides. And if both sides match, then your limit is that value. Right? So here's our definition for that is we have, it says, assume that f is defined for all x near a except possibly at a, then the limit as x approaches a, some function equals a y value, if and only if the limit as x approaches a from the left or the right, doesn't matter, equals L, and the limit as x approaches a from the left also equals L. Right, so they have to equal the exact same value, which is exactly what we have going on here. So then we can define the whole limit. So if the limit as x approaches a from the right, let's say it equaled L, and the limit as x approached a from the left equaled something other than L, then our limit as x approaches a in general does not exist. They have to match. And so that's what happens when they don't line up and don't match each other. We just say that it does not exist. Right. And then we'll have one more example. This one's going to take a little bit of work because of the absolute value. So this absolute value is going to be kind of situational, and we have to kind of consider both situations and kind of work through that math. At the end of the day, we're going to create some sort of a graph much like this, so that we can really take a look at what's happening on the left side, what's happening at the right side of whatever value they're looking for.